Good morning and welcome back to Elementary Algebra. I am Amy Fuchsteiner, your instructor for this course, and we are going to be going over section 3.4 today. That is rate of change and slope. So we're going to want you to be able to find the rate of change, the slope of a line given the graph of that line, or any 2 points from the line. We want you to recognize the different types of slope, including positive, negative, horizontal slope, and vertical slope. And then we want you to use the slope of a line to graph that line. In the end here, our hope is that you're able to also determine parallel and perpendicular as a comparison of two lines using just their slope to determine that. All right, so let's begin by talking about the rate of change. The rate of change is a comparison of two different functions of a graph, or two different characteristics, I should say, of a graph. So we're going to compare two different characteristics. Of some data or information generally presented in a graph. The change between 2 points is written as a ratio. The ratios do not have units on them, the rates do. So here's what we have. We have a graph of the GameStop stock prices from January 2021. What we're going to do is we're going to compare the number of days on the market to the price increase or decrease of that stock, right? So if we take a look at this, we see we want to compare January 15th to January 22nd. So we are going to compare the change in the price of the stock to the number of days. All right, so we want to compare January 15th to January 22nd. So we're going to take a look here and we're going to find January 15th and the price. And then we're going to find January 22nd and the price. Okay, the change in the price is the difference between 65.01 and 35.50. The number of days is the difference between January 22nd and January 15th. Using my trusty calculator, I'm going to take 65.01 and subtract 35.50. This gives me $29.51. So there is a $29.51 difference in price. 22 minus 15 is 7. This rate of change means that at this rate, the market changed $29.51 every 7 days. Okay, that is the rate of change. If we take a look at the rate of change from January 27th to January 29th, the idea here is that we find January 27th and we find January 29th. And we look again at the change in price. As compared to the number of days. So in this case, the change in price would be $325 minus $347.51. And then we'd have 22 minus 27. So using my calculator, I can scroll up there. I have 325 minus 347.51. That's a negative 22.51 for 2 days. So the rate of change from January 27th to January 29th indicates that the stock price is going to fall or be a negative 22.51 every 2 days. Okay, this would be the rate of change from January 27th to January 29th. Now, this GameStop stock price graph is rather erratic. The rate of change is not consistent because stock prices go up and go down. If you're at all familiar with this, you probably know that GameStop, the stock prices started in the month of January at just under $18. And you can see here at the end of January, that same stock was worth $325. Google it. It's really pretty interesting. All right. In a line that we graph for our course, where we are right now and what you're learning, the slope of a line can be found using the same method, finding 2 points on a graph and the difference between them. However, our graphs, for the most part, are going to be consistent, meaning they will be lines. So when you're graphing a line, you can use the same method. You can calculate the slope of the line by finding 2 points on that line. For example, this blue line, I have 2 dots delineated here, and we can see that these 2 dots have coordinates. For this first dot, the coordinate would be back 1, up 1, so -1, 1. This is why we practice this in the very beginning. The second point would be over 2, up 7, or 2, 7. Right? If I'm going to find the slope of this line, I'm going to use something called the slope triangle, where we compare the rise to the run. Okay? Our slope, or M, why is it an M? I don't know. I think it stands for the movement of the line. This is the way the line moves from one point to the other, and that's why we use slope. But there's all kinds of reasons why it could be an M. I just like M is the movement of the line. From left to right, we're going to go up 6 and over 3. That's up 6 and over 3. So our slope is always the rise compared to the run, and it creates this triangle here. Rise, run, 6 over 3, which we would reduce to 2 over 1, which is the same as 2. So the slope of this line is a 2. I can tell so from the graph. The red line is very similar. I have a point here at -6, 2, and I have a point here at 3, -4. If I create this slope triangle, the idea here is that this is a rise, but it's actually a fall. And we're going to fall 6 units. I'm going to make it negative because we're falling. And then we're going to go over, what is that? 6, 10 units. So for this one, our M would be a -6 because it's falling 6. And then we're going over 10. This does reduce. You always want to reduce your slope to a -2/5. Okay. The slope is the ratio of the change in the rise to the change in the run. All right. Now, that's looking at a graph. We just need to find 2 points on a graph. We can also do this using the points themselves. If we're going to use the points themselves, the one thing I kind of want to introduce you to a little bit here is this idea of subscript. Subscript notation is something that we use a lot in algebra, and it can be confusing, so I just want to talk to you about it for a minute. This x sub 1, y sub 1 is not times or multiplication. It just means x from the first point. And then y from the first point. And rather than write all that out, we just write x with a little bit of a 1 next to it. Subscript, tiny, dropped down, right? So x2, y2 means x from the second point. Y from the second point. So this is meant to be a cardinal number, not an ordinal number, meaning it's giving you placement, not value. All right. So formula for the slope is the change in the rise. And since our rise is determined by our y values, that means we need to determine the change in the y values. The change in the run, that's the across, is the change in our x values, because our x values determine whether we're moving left or right. Notice I have listed this as y2 minus y1 over x2 minus x1. This is fine, but you can also write it as y1 minus y2 over x1 minus x2. The order, which point is first, which point is second, does not matter really, except you can't switch it up. You can't take y from the first point and then take x from the second. The first point stays first, and the second point stays second. So it's always first minus second, or you can do the second minus first, second minus first. The other thing of note is that your x's cannot be the same. If your x's are the same number, if x1 and x2 are the same number, then you set up division by 0, and only Chuck Norris can divide by 0. We cannot. What does this look like in practice? I have several examples down below here. Our slope is y sub 2 minus y sub 1 over x sub 2 minus x sub 1. To delineate which is which, I'm going to come up here and in orange, I'm going to write an x sub 1 here, y sub 1 for the 3. So this is point xy. Since it's first, since it showed up first, I'm going to call it x1, y1. This then would be xy, but this is my second x and my second y. So x2, y2. That means when I make my substitution, I have to do y2, which is 6, minus y1, which is 3, over x2, which is negative 2, minus x1, which is 10. 6 minus 3 is 3. Negative 2 minus 10 is a negative 12. This is a negative 1/4 for my slope. What does this mean? This means that it's going to fall 1, and we're going to go right 4. So the way that this line will move is that it will fall 1 and go right 4. Let's try the second one. The second one, I have x1, y1, x2, y2. So my slope will be y2 minus y1 over x2 minus x1, or 48 minus a minus 3. Remember, minus a minus is a plus, right? So 48 minus a minus 3 over 16 minus 0. And that's going to be 51 over 16. Does this reduce at all? 51 is only divisible by, I think, 17. So it's not going to work. This is it. What does this mean? This means that it's going to rise 51 units for every 16 units left. I'm sorry, 16 units to the right. Positive. Okay, we're going to rise 51, and then it'll go 16 units to the right. Just to prove a point, what if I did y1 minus y2 over x1 minus x2? What if I switched it around? If I switched it around, then it would be, let's try a lighter purple. Okay, if I switched it around, I would have a negative 3 minus 48 over 0 minus 16. Negative 3 minus 48, 0 minus 16. That's going to be a negative 51 over a negative 16. Do you see how you still get the same answer? The only thing that was different were both signs came out negative, which would still be a positive. So it would still get me to the same answer. So if you do them in a different order, you should still be able to get the correct answers, even though the process in the middle might look just slightly different. Right? Let's try number 3. The slope would be the y2 minus the y1, 1 minus a negative 9, over x2, negative 11, minus a negative 1. That's going to be 10 over a negative 10, which is the same as 1 over 1 with a negative. So I'm going to do negative 1 over 1. Keeping in mind that negative can go in several different places. So my slope here would be fall 1, and then we would go right 1. Okay, it's worth noting that this is the same as negative 1, and that in some cases you will be asked to simplify this even further as negative 1. But to begin with, I really like to show both places or both sort of placeholders because slope is a comparison of two numbers. And sometimes that bottom number is a 1. And if we leave it off, you have a tendency to forget it. So negative 1 over 1 is the same as negative 1. But this clearly shows both parts of that slope, fall 1, right 1. Okay? What do we do if there are fractions or if there are decimals? The idea here is that you always want your slope to be a ratio of two whole numbers. So negative 1 and 4, 51 and 16. I don't want to have decimals in the answer. So my slope here would be a negative 0.2 minus a 0.8 over a negative 1.5 minus a 4.5. That's going to give me a negative 1 over negative 6, which will reduce to be 1/6. What does this mean in terms of my slope? It means my slope will rise 1 for every 6 to the right. That's the way my slope is going to move. We're going to rise 1 and go 6 to the right. Okay. So we have found the slope of a line with a graph, and we've practiced finding the slope of a line with 2 points. Now we want to talk for a minute about the different types of slope. There are 4 different categories for slope. The first slope is known as a positive slope. This will happen if your line is oblique and rising. So if from left to right, your line is oblique and rising, that is considered to be a positive slope. The equation will usually look like ax minus by is equal to some value of c, positive or negative, or y is equal to b over a plus or minus c over, those should be over the same thing. What did I do there? This should be a, this should be b. I flipped those. There we go. Yep. Sorry about that. Typo. I flipped that. That should be a over b plus or minus c over b. That means your slope, I flipped them. There we go. Yep. There we go. All right. Sorry about that. Flipped them out. Okay. So rising, positive. You'll have some positive number times x plus or minus some value. Your slope will always equal the a over the b. A over the b. From your standard equation, your slope will always equal the a over the b. A negative slope is an oblique line falling. Again, you will have ax plus by is equal to some positive or negative c. Your y will be the opposite of a over b plus or minus c over b. And your slope would be a negative a over b or a negative a over b or an a over a negative b. Notice where that negative is. It could be in front of the whole thing. It can be with a. It can be with a b. It could be any one of those places, and that's perfectly fine. A zero slope only occurs with a horizontal line. We talked about this just for a minute before. It will look like some by is equal to a c, or your y will be a negative c over b. Positive negative c over b. There we go. So what happens here is that there is no x in the equation. It is just going to tell you what y is. Notice for both the oblique lines, again, you had both the x and y values in there. And then when you only had a y, you got a horizontal line. Likewise, when you only have an x, you get a vertical line. Now, the slope of a horizontal line is 0. Right? Horizontal, we talked about that, how I spell it with a y. And that's how I remember that it's the y equals, that's a 0, horizontal. The vertical line has an undefined slope. M is going to be some number divided by 0, which is undefined. So we don't say slope is something over 0. We just say the slope of that line is undefined. These are the 4 types of slope that we want you to be able to recognize. Positive occurs if you have an oblique line rising. Negative occurs when you have an oblique line falling. Zero slope is a horizontal line. Undefined slope is a vertical line. Okay? You can recognize these simply by inspection, which means by looking at it, or you can watch for the patterns in the numbers. Okay? All right. We also want you to be able to use the slope and a point to graph a line. This is a lot simpler than it seems. Remember I talked about how the slope is m, or the movement of the line? So here we have a slope of -4 through the point 4, 2. If the m is a -4, this is the same as -4 over 1. Why do I write it that way? Slope has 2 parts, the rise and the run. If you're just seeing -4, you cannot see both parts, the rise and the run. You're probably only recognizing the rise here, which can cause a problem because you can't create the triangle if you're just rising. Okay? So if you rewrite that as -4 over 1, then you can see both the rise and the run. The point is 4, 2. So what we're going to do is we're going to plot this point 4, 2. So from the 0, 0, I'm going to go over 4 and up 2. And I'm going to plot that point. Then I'm going to use the movement of the line to plot additional points for this line. This says that I'm going to fall 4 and go right 1. So from here, I'm going to fall 4 and go right 1. And I can keep doing that step. Fall 4, right 1. When I cannot fall any further, when I cannot fall any further, I can move that negative and say, okay, a -4 over 1 is the same as 4 over a -1, which means I would rise 4 and go back 1. That should be the same. So now I've got 4 points, and I can graph my line. Where's my straight edge? Okay. Now, when you do this on WebAssign, when you're doing your homework, I believe you only need to do 1 point, right? So you would only need to plot that first point at 4, 2, and then fall 2 and go right 1 to get the second point. Right? What about a line that passes through -5, -1 with a slope of 2/3? Finding my 0, 0. I'm first going to go back 5, 1, 2, 3, 4, 5, and go down 1. And then I'm going to use my slope, or my m, of 2/3 to rise 2 and go to the right 3. I can rise 2, right 3, rise 2, right 3. And I could keep going. It's worth noting that this is also the same thing as a -2 over a -3, because negative over negative is positive. This changes my movement ever so slightly, but keeps me on the same line. I'm going to fall 2 and go back 3. Notice how that stays on the same line. Here we go. All right, so there's the second line. Now I need a slope of 0 through the point 3, -2. So the idea here is we're going to plot 3, -2. So I'm going to find 3, -2. There she be. In my tiny little graph, over 3, down 2 from the origin. And a slope of 0. A slope of 0 is a horizontal line. Horizontal. So a 0 slope is a horizontal line. Flat line. Okay? And I know this because when I see slope of 0, I know that has to be a horizontal line. All right, last one, a line is passing through -2, 6. So I'm going to go ahead and plot that -2, 6. -2, 6. There we go. And has an undefined slope. Undefined slope, I know, I recognize as a vertical line. That vertical line has to go through the point -2, 6. So it's going to go vertical, and I've got to go through that point. So anywhere on that line, I can plot a second point and draw the line. Okay? Positive slopes, negative slopes, 0 slopes, and undefined slopes. All right. Last bit on this is parallel, perpendicular, or neither. So how do we determine parallel lines? How do we determine perpendicular lines? And how do we determine if there's no such relationship, neither perpendicular nor parallel? If you have parallel lines, the graph will look similar to this. These are 2 lines that have the same movement and keep an equal distance. They're always the same distance apart. The definition of parallel lines is that their slopes have to be equal. Lines are parallel if their slopes are equal. Parallel lines will keep the same distance apart and will not intersect. The equal slopes is our tell. The perpendicular lines will have an intersection point, and they will intersect at a right angle. No matter how tilted they are, those 2 lines will intersect at 90 degrees. Our tell for perpendicular lines is that their slopes, if you multiply them together, will equal a -1. The product of the slopes of perpendicular lines is a -1. That is, the first slope times the second slope has to give you a -1 when you multiply it. What that looks like is that the 2 slopes will be reciprocals and opposite signs. Okay? Lines that are neither parallel nor perpendicular will intersect, but they will not intersect at a right angle. They'll make an X, but that X will not be a perfect cross X. It'll be like a condensed typeset kind of thing, right? It is worth noting that anytime you have a vertical and a horizontal line, those two lines are automatically perpendicular to each other. It is also worth noting that all horizontal lines are parallel to each other and vertical lines are parallel to each other. Vertical and horizontal mixed must be perpendicular. Okay. We're going to take a look at some lines and their slopes, and we're going to see if they are parallel, perpendicular, or no relationship at all. Okay? So our first slope is the points 5, 3, and 1, 4. So we're going to find the slope between the 2 points 5, 3, and 1, 4. So we will do 4 minus 3, that's y2 minus y1, over x2 minus x1, or 1 minus 5. This will give us a 1 over a negative 4, which is the same as a negative 1/4. If we do the second slope, the second slope, or M2 if you would like, M2 would be a negative 5 minus a minus 4 over 1 minus a minus 3. That's going to be a negative 1 over 4. So as you look at this, M sub 1, or the first slope we found, was a negative 1/4. The second slope we found was a negative 1/4. So M1 is equal to M2, and these two lines must be parallel. And the symbol, by the way, for parallel is just this pair of parallel lines. Looks an awful lot like a quick of that one. Okay, let's try number 2. Whoops, sorry. Okay, well, that's weird. Number 2, the slope of the first, between the first slope, would be a negative 8 minus a negative 3 over 8 minus 8. This is negative 5 over 0. I cannot have a slope over 0, so M1 is undefined. The second slope, or M sub 2, would be a negative 4 minus a minus 4 over 22 minus 11. This would be 0 over 11. M sub 2 is 0. If you have a slope that is undefined, keep in mind that this is a vertical line. Your second slope, or M sub 2, is 0. This is a horizontal line. Since one is a vertical line and one is a horizontal line, we know that M1 has to be perpendicular to M2. So in the second case, we have a horizontal and a vertical line. While they are not opposite reciprocals, we do have a note here to remind us that any vertical line is perpendicular to any horizontal. Since this is a vertical and this is a horizontal, I do know that these two lines are perpendicular. Right? Let's try 3. Number 3 says our M1 would be 6 minus a minus 4 over negative 3 minus 0, or 10 over a negative 3. That's a negative 10 over 3. I am not going to change that to a mixed number. Your slope is a ratio. It needs to stay 2 separate numbers. All right, M sub 2 would be negative 7 minus a minus 4 over 11 minus 1. That's going to be a negative 3 over 10. So let's take a look at M1, which is a negative 10 over 3, and M2, which is a negative 3 over 10. They are reciprocals of each other. 10 over 3 and 3 over 10. Those are reciprocals of each other, but they are not opposite in sign. Both of them are negative. So there is no relationship. This is a neither. Right? If I want to, I can do a quick check. I know that if I take a negative 10 over 3 and I multiply it by a negative 3 over 10, I get a positive 30 over 30, which is a positive 1. I need to get a negative 1. So even though I'm close, this would be a neither. Yep, neither. Okay. Problem number 4. Our first slope would be 1 minus 4 over 2 minus 1. That's going to be a negative 3 over 1. Notice I'm keeping both parts. Slope 2 would be negative 4 minus 1 over 3 minus 1. That's a negative 5 over 2. Yeah. Those two are neither. There's no relationship here, right? 1 minus 4, nope. 2 minus 1, nope. Negative 4 minus 1, nope. 3 minus 1 is 2. Yeah, no, this is another neither. There's no visible relationship here. The slopes are not the same. They're not reciprocals. They're not even opposite in sign. They're both negative. So there's absolutely no value or no relationship here. They're not parallel nor perpendicular. I don't know about value. They could be very valuable. All right. So 3.4, covered the rate of change, the slope of a line, finding the slope of a line from a graph, finding the slope of a line from 2 points. We went over the difference between positive, negative, 0, and undefined slopes. We used that slope and a point to graph the line, and we just got done with some parallel and perpendicular. If you have any questions or concerns, please don't hesitate to reach out to me. The Math Center is also available for drop-in help if you need anything from them. All right? Thank you.